All right, so now let's look at the second page of lesson 9.2, where we're going to discuss minimums and maximum values. So a big piece of what parabolas are used for is to determine how a given situation hits a max or hits a min depending on how it's shaped. So we're just going to look at the value side of that, and eventually you would apply this in other classes to actual story problems. So this is based on the fact that our graph can look one of two ways. It can open up, or it can open down. In both cases, we still operate off of a vertex, but that vertex is either the lowest point or the highest point of the graph. So dependent on which type of graph you have, you will either create a minimum or a maximum. So when it opens up, the vertex becomes the minimum value. Remember, we know this is the case because our A is going to be greater than 0, meaning we're looking at a graph that opens up. So back to the fact that we can find out a lot of information just based on that leading coefficient and whether it's positive or negative. Similarly speaking, if it opens down, we have what we like to call a maximum. A lot of physics is based on this because if we throw something up into the air, it's going to come down in a parabolic shape, hitting a maximum height, and that's just some future use you may use this for. Again, we know it's going to open down because the leading coefficient is going to be less than 0, and that's something we've seen in both the lesson 9.1 video and the 9.2 part 1 video. However, when you are asked to find the max and min, you're going to have to try to make some connection between the max and the min, meaning that you need to figure out the vertex of the parabola. What this is going to lead back to is your ability to remember the formula that goes with this. So, as we do this last example for these notes, what we're going to look at first is how do we determine if it has a max or a min. Then what does the process look like to determine if it actually has a minimum or maximum, or what the value is of that minimum or maximum. So first, since these are already written in standard form, let's focus in on our first value. So we have a -3, and technically on this part B, we have a 1. Since -3 means that this will open down, we would state that this particular equation possesses a maximum. If you ever forget, because sometimes it kind of seems backward that down means max. If you ever forget, just draw a quick sketch of it so that you have it. All right. So similarly speaking, we know that this one's going to open up. Thus, part B would have a minimum. That should be the quick and easy part. The harder part, or the part that's a little lengthier, is actually evaluating what this is. So we don't really need to know the axis of symmetry since all we're being asked for is the max or min. However, finding the x-coordinate of our vertex does involve the same formula. So let's go ahead and first identify our A, B, and C, and then we can plug that in to find our vertex. So A is a -3, B is a -12, and C is a 10. Again, C is not a big piece to what we're trying to accomplish here, but it's not a bad idea to practice identifying it. So the formula for the x-coordinate of our vertex is opposite of b over 2a. So I'm going to duplicate that from page 1 of these notes. So in this particular case, it'd be the opposite of a -12 divided by 2 times the -3. This should give us a positive 12 divided by a negative 6, which equals a negative 2. So that's our x-coordinate. However, if we're trying to figure out how high or low a graph is, that is not the x value portion. Because of our x-axis running left to right, this tells us how far left or right of the axis our graph is. So to actually find this value here, we need to know the y-coordinate. So what we're going to do is we're going to plug this negative 2 in to our original equation. It is written in function form. If this part kind of freaks you out, just note that's the same thing as a y there. So we have y equals a negative 3 times a negative 2 squared. Remember, order of operation, the squared will happen before the multiplying of the negative 3. Then minus 12 times a negative 2. And plus 10. And I believe this gives us a value of 22. So the value of the maximum for this graph is located at the y-coordinate of our vertex, which for this particular example is at 22. Now, if you'd like to pause, anytime we do like a duplicate type of problem, feel free to pause so that you can work out the next problem on your own. See if you get the right value, then you can watch the video or push play and see if it works out correctly. So feel free to pause if you'd like so that you can see how you do on your own. So for part B, A is 1, B is 7, and C is 8. Our x-coordinate is the opposite of b over 2 times a, so the opposite of 7 over 2 times 1, which should give us a lovely decimal of a negative 3.5. We're going to plug that in, so y equals a negative 3.5 squared. Let me change my color there. Plus 7 times a negative 3.5 plus 8. And I believe this gives you a value of a negative 4.25. So this particular graph, which opens up, has a minimum of a negative 4.25. And that is how we find max and mins of a quadratic function. Yay, math. All right, that finishes out